Topographic Maps. Click on the title to link to the Fusion textbook for additional information. Make sure your textbook is open on the portal. So before we go into our online textbook, let's review our I can statement. So today I can interpret topographic maps and satellite views to identify land and erosional features and predict how these features may be reshaped by weathering. So what you want to do is go to your portal, click on Think Central. That's just going to open your textbook, so then you can come back here and click on this link and it will bring you right to the page that I would like have read to you. So we're just going to preview this, make it a little larger so we can read. And I'm going to play the speaker.
Topographic maps. What is the topography like where you live? Is it mountainous, hilly, or flat? Topography is the shape and size of the land features on Earth's surface. A topographic map shows the shape of Earth's surface with lines that represent different elevations. These lines trace out the shapes of features such as mountains and basins. Topographic maps use different symbols to show a variety of natural and human-made features, such as rivers, lakes, cities, and parks. You might see erosional features, such as canyons and cliffs. You might also see depositional features, such as alluvial fans, deltas, and floodplains. Most lines on a topographic map are called contour lines. A contour line connects points of equal elevation. Look at the map to the right. Each line traces along one elevation. The shapes formed by the contour lines show the shape of the land. Contour lines are usually curved and smooth. The characteristics of contour lines are summarized in the list below. All points along a contour line represent a single elevation. A contour line forms a complete closed loop. You may only see part of the loop if a contour line runs off the edge of a map. A contour line never forks or splits apart. Contour lines almost never cross. Contour line spacing depends on the land's steepness. Closely spaced lines represent a steep slope. Lines spaced far apart represent a gentle slope. It is important to note which units are used when interpreting a map. In the United States, many topographic maps show elevation in feet and distance in miles. In other countries, maps use SI units, such as meters and kilometers. Topographic maps are used by many different people, including hikers, scientists, and land planners. Topographic maps, as well as geologic maps, physical maps, aerial photos, and satellite images, are important sources of information for the earth sciences.
Okay, and I'm just going to pause it there.
Compare. States many
Okay, what I did want to show you that this is a topographic map of this island that's right here. So you can see that the top with marked X is 715 miles. Okay, and it's going by contour intervals of 100. So 100, 200, 300, 400, etc. Okay, so actually it's not telling you, well, that measures 1 mile. Okay, so that was part of our textbook. Let's go over some background information as some practice. So topographic maps differ from other maps in that they contain many thin curved lines that appear to wrap around certain areas. These lines are called contour lines. They connect points of equal elevation. This means that if you were to walk along the ground represented by a contour line, you would never go up or downhill. A topographic map will tell you whether an area is very steep or is flat land. Places where lines are close together are very steep, where the lines are far apart and the land is relatively flat. In the United States, we measure elevation beginning with 0 feet at sea level. Rules. Rules for contour lines. Okay, all points along the same contour line are the same elevation. All contour lines eventually connect themselves. Contour lines never cross each other. Contour lines never split or branch. And if you click down here on this video, you can watch a video on contour maps. And I'm just going to play a little bit and pause, but you can come back in and play the rest of the movie.
Hey there. So the goal of today's video is to better understand what exactly a topographic map is, including what it shows and how to use the different features on the map to help better visualize the area that you're looking at. So let's jump right in. The first question we want to answer is, what exactly is a topographic map? Well, a topographic map, it represents a region, and it shows all of the geographical features of that region, including three-dimensional features like hills and valleys. The ultimate goal of a topographic map is to display these three-dimensional features with ups and downs and cliffs and slopes, rivers and streams, all of these three-dimensional features, but on a flat two-dimensional map. So let's take a look at an example. Here you can see a simple topographic map, often called a contour map. And the feature that should jump out to you on this map are all of these dark squiggly lines all over the place. Those lines end up being the key to topographic maps. They're called contour lines. So, what exactly is a contour line? Well, those contour lines that you saw running all over the map, those show the shape of the land, and they do it by connecting points that have equal elevation. Let me give you an example. Here's that map again. So if I look at point Y on the map, I know its elevation is 500 meters, and I know that because point Y is located directly on the 500-meter contour line. And so, by understanding contour lines, I know that any point on that line is going to have that same elevation. Of course, the other lines represent different elevations, and we'll look at that in a moment. So, let's take a closer look. One of the things you might notice is that some of these contour lines, not all of them, but some of them are labeled. For example, the 500 line is labeled, the 600 line is labeled, and these labeled lines have a name. Those are called index contours. And these are contour lines that are clearly labeled with their elevations. Now, unfortunately, on most topographic maps, there's just not enough room to label the elevation of every single line. And this is why we use index contours, maybe every second line, or every fifth line, or every 10th line, depending on the map. Either way, oftentimes you will be given what's called the contour interval. And the interval tells you explicitly the amount of elevation increasing or decreasing with each line. Now this map is clearly labeled with an interval of 50 meters. And what that means is that as you go from one contour line to the next, there's going to be a change in elevation of 50 meters. So that contour interval tells you the elevation change from one line to the next. Fortunately, even if you're not given the contour interval, you can usually figure out what it is by examining the lines, and we'll see an example of that in a moment. Let's look at some other map features. Most maps are going to include a map scale, and this lets you determine the real-world distances between points as represented on the map. So for example, let's say I want to know how far apart points Y and Z were in the real world. I could use this map scale to figure out how many kilometers apart they are. A future video will take a look at how exactly we use a map scale. Finally, we'll notice that we also have a compass rose, and this is going to tell you the directions on the map and how they correspond with real-world north, south, east, and west.
Okay, and I'm going to pause it there, and you can finish that video by clicking in your copy and watching that. So for our activity today, each drawing below breaks a rule on a topographic map. We're going to match each rule that's broken in each of the drawings below and place the number in the box. So, rule number 1, all points along the same contour line are the same elevation. So I want to find a picture that's breaking that rule. So if we look here, we have an elevation of 1,400, then it goes 1,300. We know that's incorrect because a contour line needs to show the same elevation. So it should be 1,400 all the way. Okay, so we could take number 1 and type 1 here in the box. All contour lines eventually connect themselves. So this is a rule. All contour lines eventually connect with themselves. So we want to find one that's not connecting with itself, okay? That one I'm not sure, so we'll go back and use process of elimination on that. So let's skip to number 3. Contour lines never cross each other. So do you see one over here where we have a contour line crossing each other? This looks like it right here. You're crossing here. This does not happen. So we can put number 3 in this box. Contour lines never split or branch. So here you have some branching here, but you also have branching here. So let's narrow that down. So contour lines never split or branch. All contour lines eventually connect with themselves. Okay, I would say that that's breaking the rule here. So this would be 3 and 2. For our connection, match each image below with the appropriate word description. So a gentle slope on all sides. Okay, it could be either of these 3. Here I see a steep slope, so it wouldn't be A, so we'll skip that and see if we can narrow it down. Round hill with 2 peaks. So it's either going to be this one or this one. I see 2 peaks, one here, one here, one here, one here. So round hill with 2 peaks. Could be either of those. Steep south side. That would definitely be A. Right? I see a steep because my contour lines are close together here. 2 peaks with east side higher. Okay, so this would be our east side. It looks like this would be 2 peaks with east side higher. This east side would be higher up because it's a smaller contour that's closed at the tippy top. So 4 we can say is B. Number 3 we can say is A. So number 2 could be D. And then a gentle slope on all sides could be C. Match each side view image with the appropriate contour lines. So here I see something very steep with a gradual slope here. So very steep with a gradual slope. Okay, could be one of these. So let's skip that one. Maybe we can compare it with this one here. Okay, so I'm thinking that this would be D, and then this would be C. You have very widely spaced contours representing the gentle slope, and then your contours are close together representing steep. And then here you have a large flat area here, so D would fit that one. Let's see, on 7 I see 2 peaks, so that's a dead giveaway there. So letter B would fit here. And then we just have a gentle slope would be A. All right, let's look at some STAR test questions. It says, this topographic map represents the elevation of an area 100 years ago. At that time, the highest point had an elevation of 214 meters. The highest point has since eroded a total of 7 meters. Okay, so now we're down from 214 to 207 because it eroded away. Which profile most likely represents the landscape today, and how do you know? Okay, well, if we're looking here, we can see that the west side is very steep because your contour lines are very close together. Okay, but we have some erosion here, and then we have a gradual slope over here. So I want to look for something very steep, looks like A, and then a gradual slope. Okay, so I don't see these other ones fitting in. I do not see two peaks here. It's just one peak here that's eroded quite a bit. Okay, this being as steep, this would be the steepest side. So I would go with A because the west side is the steepest, and then your east side has the gradual slope. Next, our test question. What is the change in elevation between point X and point Y? So what you have to do here is look at your contour intervals. Below here, it said contour intervals of 20. So you want to find out what is the elevation of the contour line on Y and what is the elevation at X. If we start at X, X is pretty simple because we know a contour has the same elevation all the way around, so X is 1,600, and Y would be, if this is 1,200, we go by 20s, 1,220, 1,240. So if I want to change in elevation, I have to take the difference between 1,600 and 1,240. So we could use a calculator for that, and 1,600 minus 1,240. I'm getting 360 is my change in elevation from X to Y. Okay, so think of it as a hiker. If you were here and you wanted to go to the top of the mountain, what is the change in elevation you must go? So you have to find out what elevation you're on and where you need to go. Star test question. What was the change in elevation for the family that took the steepest path to point X? So here's point X, the top of your hill or mountain. It's 600 meters. We need to know which one took a steeper path, W or Y. Since the contour lines are close together here, I would say Y took the steepest path because here your contour lines are further apart. So, knowing this is the steeper side, we want to take the change in the elevation for this family. So you have to find out, well, what elevation are they on, and where they want to go is 600, so you have to take the difference. So if it goes by intervals of 20, 440, 460, 480. So we could use a calculator again, and we want to take 600 minus 480. And we're getting 120 is our difference in elevation. Okay, and then another STAR test question. A student stands at the point marked X on the topographic map. What height in meters does the student need to climb to reach to the top? So the top of the mountain is 303. That's what that little triangle represents, is the tippy top. So we need to know, well, what elevation is the student on? And he wants to reach 303, so we have to take the difference. So intervals of 10. So it goes 10, 20, 30, 40, 50. So the student is at an elevation of 50 meters. So we want to take 303 and subtract 50 meters. And that would tell us how much he needs to go, which is 253 meters. Okay, well, that was topographic maps, and I hope that was helpful.